All right, let's jump right into this explainer. Have you ever looked at a chaotic, dusty construction site, just mountains of scrap wood and demolition debris, and thought, man, that right there is a high-purity digital asset waiting to be unlocked? Yeah, probably not. But today, we're doing a deep dive into a radical concept that is doing exactly that. We're looking at the 905 Wood Digital Refinery's workflow. This system takes completely unpredictable, dirty physical waste and uses some incredibly advanced edge and cloud AI to transform it into structured, high-purity biocarbon data. It is a fascinating look at how bleeding-edge tech is being used to solve some incredibly messy physical problems.
Okay, so here's our agenda for today. We've got 6 sections. 1, the wood waste crisis. 2, building the Sentient Bridge. 3, Edge AI on Pixel 11 Pro. 4, the GPT OSS 120B core. 5, compressing AI with TurboQuant. And finally, 6, minting the circular bioeconomy.
Section 1. The Wood Waste Crisis, Approaching the Capacity Cliff. So, to really understand why this digital refinery was built, we have to start with a massive, multi-layered regulatory nightmare that's currently facing Ontario's waste infrastructure. And it brings us to this central question. How do you bypass a looming industrial crisis using advanced tech? Because, let's face it, traditional waste management is entirely physical, right? It's just trucks moving piles of garbage into giant holes in the ground. But those holes are filling up fast, and the borders are closing.
We are looking at a perfect storm here. First up, in August 2026, there is a massive 50% U.S. tariff surcharge hitting wood transit. That basically chokes off cross-border disposal. Then, flash forward to 2029, and dumping clean dimensional wood waste in landfills becomes practically criminalized under provincial mandates. And then, the absolute brick wall hits in 2034. That's when Ontario's permitted landfill capacity, which is somewhere between 32 to 45 million tons, is completely exhausted. The traditional physical route is quite literally a dead end.
Moving on to Section 2, building the Sentient Bridge, translating physical waste to digital data.
Let's look at how 95 Wood engineered a technological bypass for these blockades. This right here is their overarching, frankly radical mission. They actually call their system the Sentient Bridge between chaotic construction waste and the high purity requirements of the biocarbon market. So they aren't just moving wood. They're taking the literal, physical chaos of a job site and using AI to distill it into something highly structured and globally valuable, biocarbon feedstock. And by doing this, 905 Wood secures Ontario's industrial leadership in the global circular bioeconomy. So what is this refinery actually producing? It mints cryptographic and compliance documents. We're talking hardware-attested manifests, USMCA cross-border shield certificates, which classify the wood as a wholly obtained good, along with carbon ESG certificates and real-time compliance audits. It takes a pile of scrap and transforms it into an auditable database. It's a total game changer. Section 3. Edge AI on the Pixel 11 Pro, rugged sovereign compliance gate. Let's talk about how this data capture actually happens out in the mud, in the dust. The contrast in their tech stack is just brilliant. Out in the field, the compliance gate isn't some massive, delicate, industrial server. No, it's actually just a standard consumer smartphone, the Google Pixel 11 Pro. That small, rugged edge hardware captures the data locally and then passes it all the way up to these massive cloud architectures running models like GPT OSS 120B and Claude Fable.
Let's break down exactly what's happening on that Pixel 11 phone because it's wild. Step 1. A cryptographic hold-to-seal root of trust is initiated. Step 2. The Tensor G6 system on a chip runs the Light-RT AI stack locally directly on Android 17. And Step 3. If the system detects any kind of anomaly, like a weird, questionable piece of wood in the pile, it escalates to a Gemini 4 Pro visual guard and an XRF sweep to confidently classify the material. It is a sovereign, secure AI agent, and it's literally sitting right in the site foreman's pocket.
Section 4. The GPT OSS 120B core, the brain of the digital refinery. Okay, so once the edge device verifies the physical load, the data hits the cloud. And this cloud model relies on an architecture called a sparse mixture of experts, or MOE for short. Think of it like a massive board of directors. Instead of asking every single person in the boardroom for their opinion on every single word, which, as you can imagine, would be incredibly slow and ridiculously expensive, the AI only consults a tiny, highly specialized subset of experts for any given token.
The absolute genius of this design is really in the numbers. To put this into perspective, the 120B model has nearly 117 billion total parameters. But, and here is the kicker, only about 5 billion of them are active at any one time. Out of 128 available feed-forward experts, the router only activates the top 4 per token. So you are getting the incredible reasoning power of a massive model, but with the speed and cost profile of a much, much smaller one.
And to keep all this complex reasoning organized, the model uses a multi-channel messaging structure called the Harmony Protocol. Step 1 is the analysis channel. This is where the AI does its raw, messy internal thinking and tool calling. Step 2 is the commentary channel for schemas. And step 3 is the final channel. This separation is absolutely crucial because it allows the system to isolate the AI's internal scratchpad. That ensures end users only ever see the final, safe, and highly structured output.
Section 5. Compressing AI with TurboQuant, Shrinking the Giant.
Now, you might be wondering, how in the world do you even run a 117 billion parameter beast economically? Well, it's all thanks to TurboQuant compression. This extreme compression shrinks the model's weights dramatically. It means the entire active checkpoint fits within a footprint of just 60.8 gigabytes. The so what here is massive, folks. It means this incredible reasoning engine can fit entirely within the 80 gigabyte VRAM budget of a single modern data center GPU, like an NVIDIA H100. You don't need some massive, sprawling, multi-node supercomputer cluster to run this thing.
And finally, Section 6, Minting the Circular Bioeconomy. Bottom line impact.
We've talked about smartphones, AI routing, and GPU compression, but how does this actually affect the industrial bottom line? Take a look at this number. Nearly $11 million. That is the massive annual savings delta achieved by the 905 Wood Digital Refinery operating at a volume of just 200 loads per week. Let's break down exactly where that money is coming from. Standard landfill disposal right now costs around $60 per ton for a massive 144-yard mothership trailer. But by digitally refining that waste and routing it directly to the biocarbon market, the 905 Wood system drops that cost to just $5 per ton. That yields over $1,053 in pure savings on a single load. But wait, it actually gets better. Remember those crushing US tariffs we talked about earlier? By using Edge AI to generate those cryptographic certificates of origin, they classify the clean wood under the HS 3825.0 wholly obtained tariff exemption. In plain, everyday terms, they're dodging a massive trade war tax. This achieves an additional $1,140 in USMCA duty deflection per load. They completely bypass the trade war via high-purity data. It's brilliant. And obviously, it is not just financial. The environmental impact is fully quantified too. Every single 144-yard mothership trailer processed yields 14.36 tons of pyrolysis CO2 equivalents. They are literally turning chaotic demolition trash into verifiable, sequestered carbon credits for the circular bioeconomy. Which leaves us with this final, incredibly provocative thought. If a combination of smartphone edge AI and compressed cloud models can solve a multi-million-dollar regulatory and physical crisis in the scrapwood industry, what other heavy, chaotic physical industries are out there just waiting to be digitized? Construction? Agriculture? Mining? The Sentient Bridge architecture really proves that the physical constraints of tomorrow can absolutely be bypassed by the digital refineries we build today. Thanks for joining me on this explainer. I really hope this sparks some new ideas for you. Catch you next time.